Alright, I hope y'all had a great weekend, and I hope you've already gotten those warm-up problems finished. Just hold on to those, and we will go over them tomorrow. And make sure your phone's in the back like I'm sure it already is. So what we're going to start looking at is section 1.3. And in section 1.3, we're talking about distance and midpoint. So for some of you, this will be a review. For some of you, this will be new, but we're just going to go over it. So you should know if you're trying to find distance, that's the length of a segment between two given points. And when we're doing problems that involve the distance formula, a lot of times we get irrational numbers, and those are numbers that can't be expressed as a terminating or repeating decimal, and typically these are square roots that cannot be simplified. So like the square root of 45, which we can simplify that to 3 square root 5, but that's as far as we can get, and it can't be simplified any further, so that's irrational. Midpoints are the points that are halfway between the endpoints of a segment, so that's going to be exactly in the middle. And then a segment bisector is any segment. It can be a segment, it can be a line, it can be a plane that intersects a segment at its midpoint. So here we have segment AB, and then if this is its midpoint, because these two parts are congruent, line L is considered to be a segment bisector. So segment BA has a midpoint, and we'll name it T. So segment BA's midpoint is T, and it has a segment bisector L, line L, that passes through T. So I want you to take a few minutes and look at these 3 questions and try to figure them out. And then we will talk about these tomorrow. You might want to come back and do these at the end of the lesson, but we'll go over these answers tomorrow and talk about what you came up with. So these 3 need to be finished tomorrow before you come to class. So we have the distance formula and the midpoint formula, and those are given to you here. So you have to have a point. Obviously, you got to have 2 points. Let me add the other one. So we have to have 2 points, and then using those points, we can plug them into these 2 formulas. So today I want you to get familiar with the formulas, and then tomorrow we'll actually prove these formulas. So make sure you have both of those written down. So we want to find the distance between -4, 6 and 5, -3. So using the formula, we're going to remember this is like x1, y1, x2, and y2. So we take the square root, and we find the difference between the x's, so -4 minus 5 squared, plus the difference between the y's, so 6 minus -3 squared. So -4 minus 5 we know is -9 squared. Don't forget those parentheses because they're important. And then we have +9 squared. So we have 81 plus 81, which is the square root of 162. Now, for all of the radicals, we want to simplify this. That means I want to make a factor tree and see if there's anything that these have in common. So I know 162 is really 81 times 2, and we know 81 is 9 times 9. So I'm going to take that pair of 9s and factor it out so that it becomes 9 square root of 2. Now, if you have another way that you simplify radicals, that's fine, but you need to make sure it is a correct method and that it always works. So if you're not sure about simplifying, you need to make sure we work on that. So that would be the distance between those points. Then we've got to find the midpoint between S and T. So remember the midpoint formula, you add the x's divided by 2, add the y's divided by 2, and your answer should be an ordered pair. The midpoint is an actual coordinate of a point. So we've got -10 plus 3 divided by 2, and then 2 plus -5 divided by 2. And we got those from doing x1, y1, x2, y2. So -10 plus 3 would be -7 over 2. And 2 plus -5 would be -3 over 2. And you can't simplify those, so that would be your midpoint. Alright, this problem's a little different. Find the coordinates of J if K is -1, 2, and it's the midpoint of JL and has coordinates at L of 3, -5. So we're trying to figure out these coordinates. So if you think about that, these are the endpoints, and we're trying to find the midpoints. We're trying to find the endpoint. So if we wanted to take these, we could plug them into the midpoint formula. So if I would be able to say, okay, well, x1 plus 3 divided by 2 would equal the midpoint, the x coordinate of the midpoint. And that should be equal to what we know the x coordinate is, which is -1. So this right here would be one equation that we set up and we're going to solve. Then to get the y coordinates of the midpoint, we would take y1, add -5, divide by 2, and we know that should be equal to 2 because that is the actual midpoint. So that's the other equation we want to solve. So to solve this, I'm going to put this over 1 and cross multiply. So I've got 2 times -1, which is -2, equals x1 plus 3. So then I subtract 3, and so -5 is equal to x1. And over here, if we put 2 over 1 and cross multiply, we'll have 4 equals y1 minus 5. And then we add 5, and we get 9 equals y1. So the coordinates of j would be -5, 9. So you use the midpoint formula, but you have to actually figure out what the endpoints are, so you have to solve the equation. So look at that, make sure you got it all written down. Some people have a hard time with this, so just visualize what we're doing and realize how it relates to the formula. So find the measure of segment PQ if Q is the midpoint of segment PR. Well, if we know if Q is the midpoint of segment PR, then these two segments are congruent. Well, if they're congruent, we know that PQ's length has to be equal to QR's length. So then we just take 9y minus 2 and plug it in, and also, plug in for QR, 14 plus 5y. So I want you to solve this, figure out what y is, and then I want you to find the length of PQ. We'll go over that answer tomorrow. Alright, segment bisectors we talked about. So it can be a segment, a line, or a plane that intersects a segment at its midpoint. So how many segment bisectors can this one segment have? Well, I could draw one, something, that just goes straight through it. But then we could take this line and turn it all kinds of directions and have an infinite number of lines that pass through that midpoint. So there's not a set number of segment bisectors a segment can have. It can have an infinite amount. So just think about all the different lines we could draw through that one midpoint. And they would all be segment bisectors because they're crossing through the midpoint of that segment. Alright, so wrap up, answer these 3 questions. What is the midpoint formula? What's the distance formula? And what is a segment bisector? And then I want you to work on, I still had the segment on. I want you to work on this assignment. You need to make sure you show your work. You need to make sure you simplify the radicals. And we'll go over this along with the other questions from this lesson tomorrow. And then tomorrow we'll also learn how to actually construct segment bisectors. So hope y'all have a good day. Good luck on your assignment and get busy.